Here are solutions to quiz number 5 for ECE 320, Spring 2022. The first problem is, given a 555 timer, find the resistor and capacitor to give you a square wave that has a 60% duty cycle at 220 Hz, meaning that the on time, when you charge through R1 and R2. When you discharge through R2. So the on time is 2.7 milliseconds, off time is 1.8 milliseconds. I know R1, that's based upon your birth date. To find R2, what I can do is take the two equations and divide them. Gives you a valid equation. Now the C and log of 2 cancels. I know R1, solve for R2, and that gives you R2 is 2 times R1, or 2828 ohms. Once I know R2, I can solve for C. C is 927 nanofarads. So there's the first problem. Problem number 2 is a transistor switch. If I want the current to be based upon your birth date, for me, that'd be 514 milliamps. Find RC and RB. Well, when the transistor saturates, VC is 0.2 volts. Giving you 5 minus 0.2, 4.8 volts at 514 milliamps, gives you RC is 9.34 ohms. The base resistor right here sets IB. IB has to be at least IC over beta, which is at least 8.57 milliamps, at most 25 milliamps, because that's all the 555 timer can output. And sometimes beta is called HFE, depends upon your textbook, meaning that RB is somewhere between 501 ohms and 172 ohms. So anywhere in that range works. Problem 3. This is the Darlington pair. This one's a little trickier. Find the voltages and currents for this circuit. So right here I've got a diode. I know that V2 is 0.7. Here I've got a diode. I know that V1 is 0.7. This transistor can't saturate because if you do, I don't have 0.7 volts across this diode. The lowest the V3 can be is when I have 0.7 plus 0.2. So this is 0.2 volts. That makes V3 0.9. So we'll check later to see if I'm saturated or if that's true. If V3 is 0.9 volts, I can solve for I4. I4 is 1763 milliamps. I4 splits and becomes I3 plus I5. I can solve for I1. I1 is 5 minus 1.4 over R, 2.56 milliamps. I know that this one's in the active region. VCE is bigger than 0.2, therefore it's active, meaning that I3 is 60 times I2. With that, I can substitute and solve, and what you wind up with is I2 is 28 milliamps, I3 is 60 times that, 1736 milliamps. And that'd be your answer. You also get I5 and I4 in the process, but here we're just asking for those two. Problem 4 is design a comparator that turns on and off at 1414 ohms, or X. So what I did is I chose this resistor. This is kind of arbitrary. I chose it to be 1414 ohms. That makes the voltage right here 2.5 volts. So that's my offset. When the resistance gets higher than 1414 ohms, I want the output to go high. So when the resistance goes above that, voltage goes above 2.5 volts, I want the output to go high, so connect with the plus input. So that'd be your circuit. Problem 5. Design a Schmitt trigger that turns on at 1414, off at 1914, and this will vary. This is based on your birth date plus 500. Trick is, first, pick a resistor. This is kind of arbitrary. If you pick 1414 ohms, then I can find the voltage at this point. The voltage at 1414 ohms is 2.5 volts. At 1914 ohms, 2.8 volts. So I have this type of characteristic, I'm going to turn on at 2.8 volts, turn off at 2.5. Since the on voltage is more than the off voltage, connect to the plus input. The offset is the voltage where you turn on, and the slope is the gain. Output changes by 5 volts as the input changes by 0.37 volts, 13 to 1. Make that a 13 to 1 ratio. So there's the Schmitt trigger that turns on at turns on at 1914 ohms, turns off at 1414. And the last problem is going backwards. Given the circuit, how does it behave? Well, I connect to the plus input, so I know I have the Z pattern. When the input voltage is large, the output is large. I know that I turn on at 3 volts. That's my offset. The gain is 4.5. 5 over 4.5 is 1.11. So I turn off at 1.11 volts lower, 1.89 volts. And then the resistances that do that. I've got a voltage divider. This is R over R plus Rx, which in my case is 1414. That's your voltage. Solve for R at 3 volts, solve for R at 1.89 volts, and you get 2121 ohms and 859 ohms. So that is quiz number 5 for ECE 320 for spring 2022.